Okay, year 11, welcome along to homework #8, inverse and composite functions, what we looked at last week in lesson. Okay, so let's read up the box up here. It says, it is important you try the questions first yourself and then you use the videos to help and correct your work. So you've got to build up a little bit of resilience. Try and do the question first, and then if you're stuck, you can use the video to help you go through it. And if you do go through it yourself, amazing. Use the video to mark your work and correct it in green pen and then hand it into my hand-in tray. Okay, so ooh, apologies, we're looking at inverse and composite functions. Just very quickly, I always keep mentioning this, but I want to make it so clear. If you want to revise these topics, first class maths is absolutely amazing. Okay, go on to GCSE revision AQA, that's your exam board, and you can search the topics here. So we're doing inverse and composite functions today. You've got amazing videos on the topic. You've got exam questions. So if you want to do more questions on the topic, there you go. You can go on to these. Amazing questions. You've got videos going through the questions. It is fantastic. And of course, the same thing for composite functions. You've got videos, questions, again, and answers. Okay, but without further ado, let's get back onto the questions on the homework. So let's begin. Question number 1 is this. We're given this function f of x is equal to 8x take away 5. Circle the value of f of -2. You just replace the x value with -2. Okay, so I put -2 in for x. Let's go and do that. So f of -2 is going to be equal to 8 multiplied by x, which is now -2, and I take away 5. Okay, so 8 times by -2 is -16, and -16 take away 5 gives you -21, and that's the answer. Okay, so that's really just basic function notation, substituting a value into the function. Question number 2. I've got the wrong mark scheme up. Oh, that's my year 10 one, that's why. Let's get this up. There we go. Question number 2, we've got this. A new function f of x is given by 3 times the x value. Circle the expression for the inverse function f inverse minus 1 of x. Now in class we were saying f of x, we're just going to write this as y. They mean the same thing. So y is equal to 3x. Okay, so f of x just really means the same thing as y. We then said step 2, we're going to switch the y where the x is and the x where the y is. Okay, so we're going to switch them over, giving us x is equal to 3 lots of y. You've then got to rearrange to make y the subject of the equation. Now to do that here, you've got 3 times y. We're going to divide both sides by 3, giving you x divided by 3 is equal to y. Okay, and then from here, we said you just replace the y with the inverse notation, which is f inverse of x is equal to x divided by 3. Now the question is just asking for this bit, okay, which we can see is going to be over here. So that's the answer. So this is the inverse function notation. Okay, inverse function. Number 3. A new function f of x is given by 8x take away 5. Work out the value of f -2. So you're going to replace the x value here for -2. Let's go and do that. So f of... Wait, have we already had this question? Yeah, okay, we've already had this question, right? Okay, that's a little bit silly for me. Question 1 and 3 are the same. Apologies, not quite sure how that's happened. So the answer again... Oh no, it is actually, it's a different question, but the exact same thing. That's weird. Anyway, we'll go through it again. Right, f of -2 is going to be equal to 8 multiplied by -2 minus 5, which gave us -21. Okay, that's the answer. Good. Question number 4. Let's go up here. And let's scroll up. A new function, x squared minus x cubed, circle the value of f -3. So wherever you see x, you're going to put in -3. Let's go and do that. So f of -3 is going to be equal to x squared. And make sure, particularly because you've got a negative, you put it into a bracket. So -3 and then squared, take away bracket -3 and then cubed. Now if we look at -3 squared, well that's going to give you +9 because you're multiplying a negative by itself twice, and we're taking away this bit here, negative 3 cubed. Now this means minus 3 times minus 3 times minus 3. This part here, we've just seen gave us positive 9. If you times that again by negative 3, well, you've got one positive, one negative, you're going to get minus 27. So the bit in bracket goes to negative 27. So 9 minus minus 27 means 9 plus 27, which will give you 36 positive, and that's the answer. Okay, question number 5, we've got this. F of x is equal to 2x squared, g of x is x plus 5. Circle the composite function fg of x. This means you're going to go and put g of x, x plus 5, in for wherever you see x in f of x. Okay, so let's go and write this. fg of x. Okay, so I'm going to go and put x plus 5 in for x here. So I've got 2, that's the 2 up here. Bracket, I'm going to replace this x with x plus 5. Okay, so x plus 5, and then you've got to make sure you include that square, squared. Now this one, it's not asking you to expand the brackets or anything. We can see here 2 bracket x plus 5 squared. I've got it down here. So this here is my answer. Good. Question number 6 is another composite function. It says f of x is given by 3 of x and g of x is given by x squared. Circle the expression for the composite function fg of x. So we're going to go and put g of x, which is x squared, in for x over here. So fg of x is going to be equal to, you've got the 3 here, 3, again, open up a bracket, we're going to go and put in x squared into x, so it's just going to be x squared like this, and close the bracket. Okay, I've put in x squared in for x. Okay, now you've got to be quite careful here because you're putting in x squared into x. Okay, the square is inside that bracket. Okay, so it's just going to literally go to 3x squared. That is 3x squared. You're not squaring the 3. Okay, you are not squaring the 3 in this case because the square just belongs with that x. So it's going to be 3x squared. A lot of people there would have written 9x squared. And that's the answer. Good. Question number 7. Let's have a look at this one. We've got this. F of x is 2x squared, g of x is x plus 5. Work out the composite function fg of x and give your answer in this form. That will become apparent as we work through it. So we're going to put g of x, which is x plus 5, in for x over here. So I'm making sure I'm showing all of my working. Fg of x is going to be equal to, I've got the 2, open the bracket up, and we're going to go and put in x plus 5 in for x over here. So x plus 5, and I'm squaring this here. Now, let's just go, because this means 2 times everything here. Let's just go and consider x plus 5 squared. Okay, let's go and do that over here. X plus 5 squared means x plus 5 multiplied by x plus 5. I'm going to go and work through and expand the brackets, okay, using whatever method you guys are going to be using here. I use FOIL. X times x gives you x squared. X times by 5 gives you 5x. I mean, you got it again, 5x. And 5 times 5 gives you 25. Collect up the like terms, 5x add 5x, x squared, add 10x, add 25. So what I've now got is, going back to up here, I've got two lots of this, x squared plus 10x, and then plus 25. I've now got this 2. I'm going to multiply it by every single term within the bracket. Okay, so that's going to go to 2 times x squared is 2x squared. 2 times by 10x is 20x. And 2 times by 25 is positive 50. And you can see now, right, you've got it in the correct form. You've got a number x squared, where that number is 2, plus a number x, where that number is 20, plus a number which is 50. Okay, so A, B, and C are whole numbers, 2, 20, and 50. There you go. This is in quadratic form. You've got a square, and this is going to be the answer. Okay, good. Let's move on to number 8 up here. Okay, this one is an inverse function. So for all values of x, a function f of x is given by this up here. Work out the inverse function. Now, our steps for this, okay, we know we're going to replace f of x first of all with y, because they mean the same thing really. So we've got y is equal to 9x plus 4, and then divided it by 7. We then swap over the y and the x value. So we're going to be getting x is equal to 9y plus 4 divided by 7. Now, I've got to go and make y the subject here. I've got a single fraction here. The first step is to get rid of that dividing by 7. We're going to multiply both sides through by 7, times through by 7, and then times through over here also by 7. I'm showing my working really carefully here. So on the left-hand side, 7 times x is just going to be 7x being equal to 9y plus 4. And of course, these 7s here, they're going to cancel out. I'm going to bring the work up here. Okay. Now, I've got this hanging plus 4. To get rid of that plus 4, we know what to do. We're going to take away 4. We're going to take away 4. I'm going to take away 4. That's going to give us, on the left-hand side, 7x minus 4 is equal to 9y. I've got 9 times y. The opposite of timesing by 9 is to divide by 9. So we're going to go and take both sides and divide them by 9. And divide by 9. And that's going to give us 7x minus 4 divided by 9 is equal to just y. And in the final step, okay, we just replace this y, okay, with the correct notation, f inverse of x. So we just go and say that f inverse of x is equal to 7x minus 4 divided by 9. Okay, and that is your answer. Okay, there we go. Perfect. Number 9, another very similar question. Okay, in the same sort of format as well, isn't it? We've got this. For all values of x, the function is given by 4x minus 3 divided by 5. Find the inverse function. The same process again. We're going to replace the f of x with y. So y is equal to 4x minus 3 divided by 5. We switch over the x and the y. So x is equal to 4y minus 3 divided by 5. I've then got to rearrange to make y the subject. I've got this dividing by 5 again. We're going to times through by 5, okay, giving us, we're going to show the working again. We're going to multiply through by 5 on both sides, times through by 5, giving us 5x is equal to 4y minus 3. Oh, sorry, that's going to cancel out. So just this. We're then going to go and add on that 3 to both sides, add 3, and we're going to go and add on 3. Okay, that's going to be giving us 5x add 3 is equal to 4y. We're going to bring the working up here. Okay, and we're going to go and divide by 4, giving us 5x plus 3 divided by 4 is equal to y. And my final step, I just replace the y with the inverse function notation. So f inverse of x is equal to 5x plus 3 divided by 4. Okay, and that's it. Okay, question number 10. Let's have a look. So this one here, this is a composite function. You've been given f of x as x minus 3 and g of x is 4x minus 7. Work out f g of x. Now, you can do this really simply. Okay, we're just got to go and find the value of g of 6. So I'm going to go and put 6 in for x over here. So g of 6 is going to be equal to 4 times by 6, take away 7, which is going to be 24, minus 7, which is going to give us 17. And now because g of 6 is 17, all I go and do is I put the value of 17 into f of x over here to give me f of 17 is going to be equal to x, which is now 17, and I take away 3, and that gives me 14, and that's the answer. You could have, and this would have been the much longer way to do it, you could have gone and put g of x into x minus 3, and then gone from there, but actually you don't need to. This is the much quicker way of doing this. Okay, so that's number 10. Number 11 is saying this. We've got f of x given by this and g of x given by this. Show that g f of 2 is an integer, which just means a whole number. So this, we're just going to work through the question, and hopefully we get a whole number as the answer. Okay, and let's go through this one. So we're going to begin by saying, well, let's find f of 2. So let's go and put 2 into f. So that's going to give us 3 lots of 2 plus 9, and then divide that all by 5, which is 6, plus 9 divided by 5, which is 15 divided by 5, which is 3. So I've got f of 2 gives me 3. And I'm going to go and put the value of 3 into g over here. So it's going to be g of 3. So g of 3 is going to be equal to 6 times by 3, take away 1, which is going to be 18, minus 1, which gives me 17. And importantly, 17 is, of course, is an integer. Okay, so we just got to really get to that number of 17, and we're all good. Okay. Nice. Part B is saying show that f inverse of 8. Okay, let's get this a bit more zoomed out. Show that f inverse of 8 is not an integer. So what we're going to go and do is we're going to go and look at f of x, consider the inverse and put 8 into that, and it's going to be a fraction. Okay, so our process for the inverse, again, we're going to replace the f of x with y. So y is equal to 3x plus 9 divided by 5. We're going to switch over the x and the y. So x is equal to 3y plus 9 divided by 5. We're going to times both sides through by 5. I've got a single fraction. I'm going to times both sides through by 5 over there. We're going to bring it up here, and that's going to give us 5x is equal to 3y plus 9. We're going to take away 9 from both sides, take away 9, and take away 9. So 5x minus 9 is equal to 3y. We're then going to go and divide both sides through by 3, divide by 3, and divide by 3. That's going to give us 5x minus 9 divided by 3 is equal to y, which we write as now the inverse function. Okay, now if I bring this over here, I'm now going to go and put in the value of 8 into my inverse function. That's going to do that. So we're going to go and say, well, what's the value of f inverse of 8? And we substitute it in for x over here. And it's going to be a fraction, so hopefully. So it's going to be 5 times by 8 minus 9 divided by 3. And 5 times 8 is 40, minus 9 divided by 3 gives you 31 divided by 3, which is not a whole number. That is a fraction. Okay, that's also the same thing as 10.3 recurring, but you can see here that this here, okay, actually that should be an equal sign, sorry. This 31 over 3 is not a whole number, is not an integer. Okay, you cannot simplify it, can you? So that's going to be the answer. Okay, there we go. And that's that one. And that's it. And that's the homework, guys. So look, it is much shorter than it usually is, but I'm now focusing on things that, you know, it's become apparent from the mocks that we've got to be making sure we have these sort of skills. This is from year 10 content. We've really nailed them. And I want to give you sort of less questions, focus in more on getting the basics correct, kind of building that confidence, making you realize that you can do this. And yeah, hopefully it was useful. Hopefully you've marked your work. You feel good about it. you've made some progress, and that's kind of what it's all about, guys. And we keep doing that over the period of time, and we're going to be doing really well. If you could drop the video a like, that would be amazing. Any questions, of course, you can comment. But keep up the good work. Well done, guys.